Okay, this is potential. V is for potential. So suppose here is a positive charge at this point, and there is a point, and there is another point like this, and this is point A, this is point B. So Harsh,
Yes, sir.
can you tell me that uh, which point from A and B has greater potential due to this charge? If a charge is placed here,
Uh, Point B.
uh, uh, actually
It's
we have
A
a we have a formula like K
Q by
R
R square. Yeah, R.
R. Please relax first. Okay, fine, no problem. I
Sir,
will
actually,
explain.
I'm not well. That's why
What?
I'm not well. So that's why I'm like kind of.
Oh, okay, okay, no problem. You will be well soon. That's not a. So the distance between these 2 points. Uh, 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 Here you can see this distance. Like this is D1, and from here to here, like this is D2. So we can say D2 is greater than D1. So
Yes.
so D2 is greater than D1, and if we put the value of D1 like V at A, so KQ by D1 and V at V like KQY, so D2. So obviously D2 is greater means VV is smaller, means
Yes, sir.
VA is larger than VB. So okay, this is just for and there is one thing more.
Hmm.
There will be the electric field also due to
Yes, sir.
the charge, due to this charge. Suppose this charge is kept at this point. Suppose this charge is placed at here. So due to this charge, there will be the electric field, and I am representing electric field with P. And and we also know about the electric field. What is the formula for electric field? KQ by R square. Do you remember?
Yes, sir. Last class. You told me.
Yeah, yeah. KQ by R square. So means from this electric field is variable. This electric field is variable means electric field is changing from A to B. Okay. So now I am supposing that this point A is at a potential. This point B is at a potential of B, and this
Yes, sir.
A is at a potential of V plus dV. And this distance is AB distance is dr. Means this AB distance is very small, and this change in potential dV is the change in potential. Okay, and we also knew that the potential of A is greater, so I have written here V plus dV. Okay, so the potential at A is V plus dV, and the potential at B is V. So we have a relation. We have a relation between this electric field and this potential minus of dV by dr. We have a relation like this. Okay, and please remember one more point, and this negative sign shows that direction of electric field, means I can say field, is from high to low potential. High to low potential. As this point is clear from this, here is potential high and here is
Yes, sir.
potential low,
Low.
and direction of electric field is from high potential to
Low
low
potential.
potential. And you should remember this formula also.
Yes, sir.
Okay. And you can also say that potential always decreases in the direction of field. Like you can see here, in the direction of field, potential is decreasing now.
Yes, sir.
No problem. That is fine. There is one question. Suppose this is a point and this is another point. This is point A and this is point B. This distance is supposed to centimeter, and potential at point A is plus 6 volt, and potential at point B is plus 2 volt. And we have to find the value of point electric field. Okay. Find electric field. We have to find the value of electric field. So we have a formula like minus dV by dr. So what is dV? dV is, here dV we can say change in potential. dV is change in
Yes, sir.
potential.
Change in potential.
Change in potential means 6 minus 2. What amount of potential is changing in going A to B? Means we can say 6 minus 2, that is 4 volt.
Yes, sir.
And we also have dr. dr means the distance between these 2 points. Like this, we have taken the distance between 2 points like this, dr. So we have also dr like 2 centimeter, and 2 centimeter, if I convert 2 centimeter into meter, I will divide this 2 centimeter by 100. Fine now? Because in 1 meter there is 100 centimeter, so we will get 0.02 meter. And now we will find the value of electric field. Here is negative sign. What is dV first? 4.
No, change in potential of 4, yeah.
Very good. And now we will put this 0.02.
0.02.
0.02. Now what will be answer? This will be minus 400. This will be minus 400 divided by 2. And if we remove this point, means you have to multiply it with 100.
Yes, sir.
Okay. So
Minus
I can
200.
this will be minus
200.
200 volt per meter. This is our answer. Simple now.
Yes, sir.
You have to put the value of potential and the separation between 2 points.
Yes, sir.
So please note it down
Yes, sir.
and please ask me to scroll down. And if you have any doubt, then please ask me. And try to be relaxed. Okay.
Yes, sir.
Should I scroll down?
Yes, sir. Done, sir.
Okay, good. Now, if potential is only changing in x direction. So if the potential is changing only in
Direction.
x
X direction.
direction, so we can find the value of electric field like minus dv by dx. And similarly, I can say for if potential is changing only in y direction, then I can say Ey will be minus dvy dy. And this statement is also true for z. If potential is changing only in z direction, I can find Ez minus dvy dz. Okay. So this is the thing, and now there is one question so that you will get it better understanding. Suppose the potential is given as like 3x square. This is x, 3x square. So it means that this potential is changing only in x direction
Yes, sir.
because there is no y and z in it. So if I want to find the value of electric field, so electric field will be in x direction will be minus dv by dx.
Minus dv by dt. Yeah.
And can I write like this, 3x square divided by dv, and this will be minus 6x simply. Is it fine now?
Yes, sir.
And if I want to find the value of electric field in y direction, minus dv by dy, now it will be 0. It will be 0, and Ez is also 0. Why? Because this potential is not changing in y direction, which means the differentiation of this v with respect to y will be 0. Okay.
Yes, sir.
Similarly, differentiation of this with respect to z will also be 0. So you should have some understanding of differentiation also. Okay.
Yes, sir.
So uh, so this is the thing. So what I have done here, I have differentiate this 3x square with respect to x. Okay.
Yes.
We will differentiate 3x square with respect to x. This is x, sorry. So x, like we will multiply 3 with 2. This will be 6, and we will multiply x. This will be 6 minus 6x. So, and Ey is 0 and Ez is also 0. Okay. And suppose now if suppose if potential is actually these are some mathematical terms, this differentiation and all that, na? So
Okay, sir.
if potential is a function of x, y, and z, then like potential is in the form of x, y, z, and I am giving one example. Like I can write v x y z like 3x squared plus 6y plus 9z squared. So here, what can I say about the potential? So potential is changing in x direction, also in y direction, and also in z direction. Means potential is changing in all the three directions.
All three
Okay.
directions.
Okay. Because this equation contains the function of potential is in the form of x, y, and z. So for this, if we want to calculate the electric field in x direction, then we will do partial differentiation of potential with respect to x, and this is Ex, Ey minus dV by dy, and for Ez this will be minus del V by del, sorry, this is not d, this is del. So Ex is minus del V by del x, Ey is minus del V by del y, and Ez is equal to minus del V by del z. And this is known as partial differentiation. So partial means not fully. Partial means the meaning
Not
of
fully.
partial. The meaning of partial is not fully differentiated, partially differentiated. So we use here partial differentiation. Partial differentiation. So now we will solve one example so as to get you understand the thing better. B, X, Y, and Z is given like 3x square plus 6y plus 9z square. And now if find electric field, we have to find the electric field. We have to find the electric field. So suppose this is y-axis and this is x-axis and this is z-axis. You can take x-axis as like this. This is x-axis. Z-axis. So means electric field will exist in y-axis also, in x-axis also, in z-axis also. Okay. And if we want to find the total electric field, so means if we want to find the total electric field, then we will take all the electric fields.
Yes, sir.
Electric field, we will add all the electric field vectorically. Means
Yes,
like
sir.
like this is E, na? And can I write this like Ex of I cap plus Ey of j cap Ez of
K cap.
k cap. So if these are the components of total electric field. This is the component of electric field in x direction. This is the component of electric field in y direction. This is the component of electric field in z
Z
direction.
direction.
And if we want to find total electric field, then we have to add these electric field vectorically. Okay.
Yes, sir.
So now can I find Ex? We have a formula for Ex minus del V by del X. The meaning of this term is here we kept constant, we consider constant y and z. Y and z is constant. This is a way of partial differentiation. If we differentiate the function with respect to x, then we have to consider y and z as constant. So this is ex. So value of ex will be minus del of del x, and what is the potential? 3x square plus 6y. 3x square plus 6y plus 9z square. 9z square. So this is the value. So I have said to you that you should keep y and z as constant. Y and z as constant means when you differentiate this y and z, this the differentiation of y and z will be zero now, because y and z is constant here. The differentiation of constant is zero. Like suppose I am saying differentiation of 5 with respect to x is zero, because 5 is constant. 5 is constant now.
Yes, sir.
So like this, here y is constant. Then if we will differentiate this y with respect to x, then it will become zero. So this I can write this like minus del of 3x square divided by del x plus minus del of 6y divided by del x plus I can write now it's fine. No, not fine. We should write this here. Now it's fine, now. So I can write this minus del of, I am multiplying this del with this, okay? Del is multiplying with 3x square and del is multiplying with 6y, del bracket 6y, and del x will be denominator, okay? Del 9z square divided by del x. And I have already told you that the differentiation of this will be, can you tell me, Harsh? Differentiation of this, do you have any idea? Okay, no problem. It means you have some problem in differentiating the terms. Am I right, Harsh? Harsh, are you getting me? Hello? Harsh, hello? Are you fine? Harsh? Harsh, are you fine?
Yes, sir. I just like I lost my internet connection, sir.
Okay, okay, no problem. Uh, so this is clear?
Yes, sir.
This thing is clear now?
Yes, sir.
So so here I have written this thing like this. Okay, I have multiplied this del minus del y del x to this term and this term and this term. So this is like this. So do you have any idea of differentiation? Differentiation, like can you differentiate this? Can you
No,
tell me
sir.
the
Like,
answer?
no, sir. I didn't learn much from 10th. I don't have much currently.
Okay, okay, no problem. That is fine. So uh, I am telling you about the differentiation. Okay, so so have you heard the name of differentiation?
Yes, sir. Differentiation, integration. I have like
Okay,
integration. I
okay,
have
oh,
done, but differentiation.
okay, okay, no problem, no problem. I'm telling. So this is for just 5 minutes. So like differentiation, I will give you a brief idea. Like here I was telling you, I have to differentiate this minus del of 3x square of partial differentiation del x. So what we do here, we will do here like we will multiply this 3 with 2. So this will be 6
6.
and we will take this x only. We will reduce one power of x. Means if there here is power is 2, means we will take one power.
X.
So can you tell me now del y del x of 5x square? What is the answer?
Sir, it would be minus 10x. Oh,
Very
sorry.
good.
Yeah, minus 10x.
Fine,
Yes.
fine, fine, fine. So now can you tell me del y del x of 10x? You should reduce if x have power 1. So 1 minus you should minus 1 from the power. Here power is 2, you should minus 1. Here is power, if the power is 3, you should minus 1, means x square, like this. So here 10 is there na, and
Yes, sir.
minus is there, and
Yes.
here what is the power of x is 1.
Yes.
So means uh,
It would remain 1, right?
1 minus 1 means x to the power 0,
0,
and x to the power 0 is 1.
1,
The power of if any number have power 0 means it is equal to 1.
1.
So this will be 10. So like if I am saying differentiate this del x of 3x cube. So remember one thing, you should multiply this with this. Okay,
Yes, sir. So it
and
will be
and
9
and 9 and reduce one power
x
means.
square. X square.
So I think now you should have some idea about this. Some idea. So should we return to our class?
Yes, sir.
So here, let's see here. And one thing I also want to tell you, always remember in case of differentiation, if I differentiate constant, the differentiation of constant will always be 0 with respect to x, y or z. Constant will y is also 0. Similarly for z, like 5 is constant now.
Yes,
5 is
sir.
constant. 5, why is the 5 is constant? Constant means the value is not changing. Constant means the value is not changing.
Yes, sir.
Okay. Now it's fine. So here the value of 5 is not changing. Suppose I am saying find dy of 5. So what is the value?
5.
0.
Yeah, 0.
0 because
0.
5 is constant. Suppose
Yes.
if I am saying dy dx of 3y and this 3y is constant. So means this will be 0 now.
0.
So
Yes, sir.
differentiation of constant is always 0.
Okay.
And with the passage of time, you will get to know these things. And please try to learn something, learn differentiation. Okay.
Yes,
Uh,
sir.
you are in 12th and you are from CBSE, na?
Yes, sir.
So I think differentiation should be in your syllabus and
It no,
in in math.
I
Yes,
don't
okay.
like in school they don't teach us because we don't have maths. So
Oh, okay. You do not have math.
no, I don't have maths, sir. I have bio.
Oh no. Actually, you are a bio student.
Yeah.
Okay, no problem. Oh, no problem. So
Like
you should tell me.
I only
Hmm.
studied till 10th maths. So
Okay, okay. So you should tell me, na. You are a student of medical student means. So
yes, sir.
from you are from where?
Like the city I live in, or
Currently, you are
uh,
from where?
currently I'm in Saudi Arabia. Sir.
Saudi Arabia. Okay, fine. That is fine, but you should have an idea of differentiation and so let's
Uh, s-
continue.
Sir, I just have a small request, sir.
Okay.
Sir, can you just finish this class at 8:30? Like I'm not feeling well, sir.
Okay, no problem. If you will say, do you know Hindi?
Yes, sir.
Do you know Hindi?
Yes, sir.
Okay, no problem. If you are not feeling well, then obviously we will discontinue this at 8:30. There is no problem. Okay.
Thank you, sir.
Okay, and get well soon.
Yes, sir.
So
Thank you.
we have 18 more minutes, so we should try to learn the thing.
Yes, sir.
So now can you please tell me
Yeah. 6 raised to power 1, sir. Oh, sorry. Yeah. Minus
minus
12.
6x?
Yeah, minus 6x. Right.
Maybe in the next class, I will discuss differentiation. Okay, so that
Okay.
you should have an idea of it because differentiation will be used in physics. Okay,
Okay.
so and this we I told you that y and z is constant means this 6y is constant and
Yes.
differentiation partial differentiation of constant will be 0
Yes, sir.
and this
0.
is also
And this will
constant
be, yeah, 18x.
also 0. Okay, so
So
means
yeah, it's
ex.
constant.
Okay
Sir, how
na
is that constant, sir?
this na.
Yeah, how is that constant? Like it should
Uh,
be 18x, right?
no, actually no. Why this is constant? Because we have said that y and z is constant when we are partially differentiating this voltage,
Okay.
this potential. I have written na here. This is the condition.
Yes, sir. Yes, sir. Okay.
Y
Got it.
and z is constant. Here z is also constant. Y is also constant. So constant
Okay.
into constant means constant, and this is
Yes.
also constant. This is also constant. So this there is a condition here. So Ex will be minus 6x. Fine.
Yes, sir.
Okay. So similarly, we can calculate Ey. And Ey for we have a formula del y dy. And now we will consider x and z as constant.
Okay.
Now let's see.
So y is not constant.
Now here x and z, the term of x and z will be constant. So if I want to calculate Ey,
Okay.
then I have to write del y del, and this will be of 3x square plus 6y plus 9z square. 3x square
Yes,
plus
sir.
6y plus 9z square. So now we can easily, so now this will be the constant now, because x is constant now. Here this term will be constant now, because we have said
That
that
should be 0, sir.
so
Yeah.
differentiation, partial differentiation of this will be 0. And for the y is not constant now.
Yeah.
Y is not constant now. So we have to write like
It will be,
minus del
sir, 6y raised to power 0.
1 minute. Right. Okay, okay. So and this will be 0 na, differentiation of this. Partial differentiation of this
Yeah,
will be 0
yeah.
na, because
Yes,
we
sir.
are
That
taking
will be zero.
z as
Yes, sir.
constant.
That will be 0.
So this will be 0.
Yes, sir.
So now you should find the differentiation of this partial differentiation. So what I have told you, 6 and
Sir, 6y is
y to the power
it will
1,
be into 1, 6 into 1.
6 into 1. Very good. This will be 6 into 1. Good. So this will be minus 6.
6.
Okay.
Yeah, minus 6. Yes,
So
sir.
similarly, we can do, if we want to find Ez, minus del y del z of del v, del v of del z. And now what is constant? X will be constant and y will be constant,
Y will be constant.
because we are differentiating with z. These
That,
are, these will be constant. So Ez, I can write minus del of 3x square plus 6y plus 9z square and del z. Now this is constant, so differentiation will be 0, partial differentiation, and this is also constant. So differentiation of this will be 0 and 1 now. Del y,
yes, sir.
del z of 9z
It will be
square.
18x.
18z means here is z, so we can write z. So like here what we will do, 9 multiply by 2,
Yeah.
and we will reduce power
Yes.
of z with 1. So what is 9 to the 18, and that z to the power 1 means z, 18z. This will be minus 18z. So now we have Ex, Ey and Ez. So we can write complete value of electric field.
Yes, sir.
Ex I cap plus Ey j
EY,
cap plus
EZ, J cap,
Ez
K cap.
k cap. So what is the value of Ex? Ex is given by minus 6x.
Yes,
Ex
sir.
is given by minus 6x, and this will be I cap. And what is Ey? Ey is minus 6. Ey
Minus
is
6.
minus 6 of j cap.
J cap.
And what is Ez? Ez is minus 18z.
18Z, sorry, yeah, 18Z, K cap.
Okay. So finally, we got the answer as minus 6x I cap minus 6 of j cap minus 18z of k cap. This is our final answer. Okay, Harsh.
Okay, sir.
So now you should have an idea about how we differentiate partially. Okay, and you should have some
Yes,
idea
sir.
also about the differentiation. So please note this question.
Yes, sir. Yes, sir. Scroll up for one minute.
Scroll down, scroll up.
Scroll up. Yes, sir.
Okay, okay. You want to note this one also, na?
Uh, yes, sir.
Okay, please note.
Just hold on.
Okay. So you do not have any idea about the differentiation earlier.
Sir, no, sir.
Okay, no problem. Maybe in the next class we will try to discuss about the differentiation and all that. Actually, these are known as mathematical tools which we are
Okay.
required to study physics. Should I scroll down?
Yes. So 1 minute, sir. 1 minute.
Okay.
Yes, sir, you can scroll down.
Okay.
So you can scroll down.
So at 8:30 you want to leave, okay?
Yes,
Because
sir.
you are not feeling well. That is fine, no problem. That's fine. Should I scroll down?
Sir, just a minute, sir.
Okay.
Yes, sir, you can scroll down, sir.
Fine. Give me a minute. Now it's okay.
Yes, sir.
This is the final answer. This is our final answer. So Harsh, please tell me, what is the topic that you are studying in your school right now in physics?
Sir, 1 minute, sir. Let me tell you. Sir, actually, like we're in the 4th chapter, moving charges and magnetism,
Okay, no problem. That is fine.
and we were studying right hand thumb rule, sir.
Hmm. Okay, fine.
Because sir, we don't have school for 2 months now. We have vacations.
Okay.
And sir, in school also, like we didn't do differentiation in this chapter for potential energy and capacities.
Hmm.
Like we didn't do this question or something like this. We didn't do. We only studied the capacitance, the potential, the formula, and that's it.
Okay.
Sudden, I wrote it.
So completed.
Ah, yes, sir.
So we have 4 more minutes, and have you understood this question, Harsh?
Yes, sir. Yes, sir. Yeah, I'm
Fine. That's good. So now I have one more point. Like if potential is constant, in the earlier examples, the potential is not constant. It is varying with x and y and z. Now, if suppose potential is constant, like we have a formula. Constant means dv equal to 0. means potential
yeah,
constant.
divisible 0.
Potential constant means these are 2 points, A point and B point, and potential at A and potential at B. So dV equal to 0 means change in potential is 0. Means when we are moving from here to here, the potential remains same. So VA equal to VB.
Yes, sir.
So that's why I am writing dV is equal to 0. dV is change in potential. Change in
Potential.
potential. So we have a formula also for calculating the electric field. In the beginning, we have done that. dV by dr.
They are
So what is the value of dV here? 0.
0.
dr means if the potential is constant, electric field is 0. So here electric field will be 0.
Second, yeah. I'll write this, sir.
And have you noted down, Harsh?
No, sir, I'm writing this.
Okay, no problem. Please write.
Done, sir.
Done. This is the last thing, and after that you may leave. This is the electric field.
Yes, sir.
Okay. This is the electric field. This is the direction of electric field. This arrow shows the direction of electric field from left to right. So there is a point A here, and there is another point B here. Now, Harsh, can you please tell me what is the relation between VA and B? Which one is greater? This is
Which one
the
is
last.
greater in potential?
Means VA is greater or VB is greater? As
Sir,
we have
VA is
discussed.
greater because electric field moves on decreasing potential.
Very good, very good, very good. Because in the direction of electric field, potential decreases. Means when we are moving in this direction, so the potential is decreasing. Means VA will be greater than
VB.
VB. Very good. So this is the thing. Don't say it as question. You can remember this like. Okay.
Yes, sir.
So that's all for today. As you are not feeling well, and get well soon.
Okay, thank you, sir.
Okay, and if you have any doubts, then please ask me.
Okay. No, sir, like it was clear today.
So Harsh, now you can leave the meeting.
Oh, okay. Thank you, sir. Bye, sir.
Okay. Thank you.